Bismillahirrahmanirrahim. Today we are going to discuss the topic of ECG. First of all, we all try to understand what ECG stands for. ECG stands for electrocardiogram. We also have another name for EKG, which is also called EKG in British. So, first of all, we have to understand what ECG means and what it records. Basically, ECG is the electrical activity of the heart, that is depolarization and repolarization. To understand ECG, first of all, we have the knowledge of electrical circuit of the heart. As you all know, we have four chambers of the heart, two atria and two ventricles. I will show you in diagram. Two atri, atrium and two ventricles. The electrical activity of the hearts begin in right atrium. Here we have a node, SA node, which has a property of generating electrical impulses on its own. Understand? We have a SA node in the right atrium which has the ability to generate the impulses on its own. From here on, we have another node, that is AV node, which is also located in right atrium at the base, at the junction where atria and ventricles unite. From SA node, the electrical impulse reaches AV node. From AV node, the electrical impulses are divided into right and left bundle branches. From here, the electrical impulses are into Purkinje fibers. Now, this electrical activity is recorded by the ECG machine on the ECG paper, which we all read and interpret the different physiological and pathological activities of the heart. So, once again, I will repeat the whole electrical circuit of the heart. That is, we have heart have four chambers, two atria and two ventricles. The electrical activity of the heart generates in the right atrium from SA node, and you all know that the SA node has the ability to generate impulses, electrical impulses on its own at a constant pace. From here, electrical impulse reaches AV node. AV node is also located in the base of the right atrium. From AV node, the impulses goes into right and left bundle branches. From bundle branches, the electrical impulses spread all over the ventricles by Purkinje fibers. This all is known as electrical circuit of the heart. Now I am proceeding to the second stage of the ECG. What are the fundamentals of ECG. As we all know, ECG have a machine. The machine and its stylus run at a pace of 25 milliseconds. Okay. On ECG, we have different waves. I can show you by diagram. P wave, Q, R, S, T, and occasionally we have a U wave. This is basically one cardiac cycle of the electrical activity, cardiac cycle of the heart. That is P wave, Q. This downward deflection is Q wave. This upward deflection is R wave. And this downward deflection is S wave. And this whole is known as QRS complex. And this is the T wave and this is U wave. Now I am going to explain the properties of P, QRS complex and T wave. As we already discussed that heart has four chambers, two atrias and two ventricles. Now the electrical activity of the heart on ECG is shown by this P wave. This P wave on ECG shows us the electric activity of the heart, that is depolarization of the ventricles. Now, whenever you see P wave on ECG, when your mind will directly goes, that is, we are talking about the depolarization of ventricle. As we all know, atria are small as compared to ventricles. The repolarization of the atria are not detected by the ECG machine and it is not recorded on the ECG paper. Now we come towards QRS. The whole it makes QRS complex. This QRS complex shows us depolarization of ventricle. As we know, the ventricle are much bigger than atria and the electrical activity recorded on ECG paper is also bigger than the P wave. As you are looking, this negative deflection Q wave, the upward deflection R wave, and this is S, and this whole known as QRS complex. And this QRS complex shows the depolarization of ventricles. As we discussed, SA node generate impulses which reach AV node. By AV node, impulses through right and left bundle branches reaches in the ventricle and the whole ventricles are depolarized by the electrical activity spread by Purkinje fibers. Now we are going towards T wave. This T wave shows the repolarization Repolarization of ventricles. As I discussed that the electrical activity of repolarization of atria are too small to be detected on ECG machine on ECG and recorded on ECG paper. As we know, ventricles are bigger than atria, so the electrical activity of the T wave of the ventricles are recorded by the ECG machine and grafted on ECG paper as T wave. So the electrical repolarization of the ventricle is shown on ECG paper as T wave. The U wave is rare and often not detected on ECG paper. Now I am going to discuss the different pathological condition and different time periods. Now, as you show, as you see that I have drawn the two electrical cycles of the heart. First of all, how you should determine the heart rate. The distance, the distance between these two are waves. As we have the distance between these two R waves are counted in the form of large big square. The number of large big square divided by 300 is the heart rate. One thing you should know the pathological condition, this ST segment. This ST segment is important for the diagnosis of MI. Whenever there is upward deflection of ST segment, there is ST elevation MI. This T wave, the hyperpolarized T wave like this indicates hyperkalemia. And the inverted T wave shows us ischemia. One more thing to be discussed with you is the PR. This is the PR segment. The time period taken by atrial repolarization and the SA node to generate AV node to generate the impulse is 120 to 220 milliseconds, and the normal QRS complex duration is 120 millisecond. Less than 120 millisecond means the SA node is generating impulses at a high pace, and the heart is tachycardic, and less than 120 millisecond QRS duration mean there is faster generation of AV node to bundle office and Purkinje fiber. Similarly, if this is prolonged, so it means there is some delay in the spread of electrical impulse from a SA node to AV node. And same is here, that is, if it is more than one if it is more than 120 millisecond, there is problem in the AV node or bundle branches or Purkinje fiber, that ventricles are not properly depolarize. Again, I am going to repeat the fundamentals of ECG. On ECG, we have P wave, QRS complex, T wave, and U wave. P wave shows on ECG electrical depolarization of the atrium. As atria are small, so the repolarization of the atria are not detected on ECG machine and recorded on ECG paper. Then come QRS complex, QRS waves. These three waves makes QRS complex, and the QRS complex shows us the depolarization of the ventricles, and the T wave shows us repolarization of the ventricles. This whole I have made for you peoples to understand. If you have any queries, you can ask me any questions. ECG stand for electrocardiogram, also known as EKG, electrical cycle, which is basically the graphical presentation on ECG paper. The pace of ECG machine is 25 millisecond, and this is all for you. Okay, thank you. Allah Hafiz.